This week we'll focus on mechanical modeling. We'll begin by modeling and rigging a hydraulic using hierarchy organization and animation constraints. We will then use that hydraulic to create more complicated mechanisms, in my case a motion base and some landing gear. Then we'll work on integrating these mechanisms into our models. We'll create control curves, do more hierarchy organization and use more constraints, and then we'll set up set-driven keys. These will enable you to easily access your mechanical animations from one centralized control. So let's get started. So this week we're going to focus on mechanical modeling. More specifically, I'm going to be modeling a motion base and some landing gear. The first thing I want to build are actually these hydraulic cylinders that are going to drive the motion base. So I have this reference image that I found of a hydraulic cylinder. I think this is based off of a construction cylinder, but I like the detail that they've added on here, and I'd like to incorporate some of that into our model. So I'm going to build something kind of loosely based on this. I'm going to be changing these joints. Really, for these motion bases you need universal joints pretty much everywhere, which would be something like this. This is actually a little more complicated of a rigging job that I like to do for this class. So we're just going to be faking this by making sort of a ball and socket joint like you would see on an action figure. So let me keep this image up just so while I'm building here. So here in you can see kind of the footprint of our motion base here, and if I shut this off you can see the footprint of one of our shocks. Now we might be adjusting these shocks when we build landing gear, but we're going to want to just build this basic shape for now. So I'll start out with a sphere and I'll rotate it and snap it into place up here. And I'm going to want to adjust the subdivisions on the axis and height both to 12. I want the height to be a power of 3 because I'm basically going to cut the center third out of this. So now let me duplicate and make the inner kind of ball. Actually, I'll duplicate and select the initial sphere just so I can change the subdivisions, because we don't need as many subdivisions on the ball. So now I'll select these faces down the center and I'll just go ahead and extrude them. And let me snap them to these sides so they're flat. And I think I'll change the pivot point here and scale them in a bit more on those two axes just so they can completely cover the ball. And now for the ball itself, I'll drop in an edge loop and extrude these top faces up. And it looks like the pivot point, when I changed the pivot point earlier, it kind of stuck there, so I'm just going to reset the tool and flatten those top faces out and drop in an edge loop. So now we've got our ball shape, and let's work on the socket some more. So I'll scale those edges in a little bit more, and I'll make sure to move that pivot to the center of the ball just so I'm scaling along that axis. Now I'll create the shaft of the hydraulic, and that could just be a simple 8-sided cylinder with no caps. Now let me grab this these faces down here, and I'll just snap them to that shape. Drop in an edge loop there, and then I'll just scale these. I'll just scale the shape around the shaft of that hydraulic. So now we've got kind of our socket shape. Let me grab all these edges and we'll just use the bevel tool. And I'll take out the chamfer, and we're getting those arrow shapes in the corner, so let me use my scale tool and kind of just adjust things out. And I'm actually going to create a second agreeable material, and it's going to be very similar to the first one, but I want it to have the same spec color values. So what you can do in that color picker window is if you change one of the parameters of the colors, it saves it in like that little shelf, so you can come back to it. So now we've got our socket shape, and we can kind of rotate it around the ball. And you can see it might crash through in certain places, but that's okay. So now for these, I'm going to duplicate them for the bottom of the shock. I'll set the step snap on my rotate tool so I get a perfect, so I can get a perfect 180 degrees easily. And I'll just go ahead and snap them down to the origin. So now I'll create a cylinder that will be the basically outer sleeve of the hydraulic, and I'll go ahead and change it to 8 sides because it's just going to be a cylindrical shape. So now looking back at this reference image, it's got a couple ridges and it's got some bolts on the top, and then these hoses. So I want to kind of recreate that look. So first I'll create these kind of ridge shapes, and I'll just grab those faces and extrude them out. Select these edges, and I'll go ahead with my bevel tool, and we'll use our typical settings, and I'll just go ahead and collapse those edges there. I have a hard time with that, so I'll just delete them both and use this split tool. Let me move these verts up so we don't have any collisions with the socket. Create my basic bolt, and let's do 1/2 centimeter for the bolt. Let's see, I'm playing with rotation a little bit here. I think I'll just leave it as is though. So let me grab these faces, and then we'll scale out so we can cover basically where that bolt is going to be. Drop in that edge loop there, and then we can scale out even more. So now for this bolt, make it basically 1/2 centimeter tall, and then I'll just bevel all those edges and delete these 2 edges just to give us that kind of basic shape. And actually I can just delete those lower faces just to save some poly count. And I'll scale them down just a tiny bit just so they fit a little better. So now I'll just change the pivot to the center, and then I'll just duplicate with transform to get them around the top of the shock. That's looking cool. It's like an extra level of detail. I also want to create these kind of ribbed pieces that go around the basically this collar on this this hydraulic. So let me just use the bevel tool, and I'll just merge those verts so we only have 1 edge loop over the top. I'll just name that greeble mat too, and then I can duplicate these around the same the same values as the bolts. And now let's create one of these valves for the side here, and I'll just do a 1.5 centimeter box. So let me run the bevel tool, turn my chamfer off, offset is fractions so it's consistent with the rest of the shock. Now we've got our 2 sort of valve stems, I guess. So now let me make a 6-sided cylinder. I'll just go ahead and delete the top and bottom faces. And now I'm going to drop in some edge loops here just so I can move this cylinder around. And then I'll cut those faces there, and then let me turn off my snap step on my rotate tool and just kind of rotate these edge loops into place so we get a nice curve on our pipe. I'll assign my greeble mat, and then you see these valves on the reference have bolts on them, so I'm just going to duplicate this bolt and center the pivot, and then I'll just put 1 bolt on each valve. just kind of adds an extra level of detail there. And so I'll group this and dupe it around. And actually I'll just, I'll have this one only go up certain ways on the stem. So having something like this be asymmetrical is kind of a quick way to add visual interest. So now I'm going through and I'm naming all these components, and I'm making sure that everything has the sort of prefix of hydraulic 1, because then we can just replace the hydraulic number as we duplicate these around. I think I'll just combine all these parts together. So I'll call this hydraulic piston A. And now I'll use comment rename to rename the bolts. I'll just quickly use comment rename to rename these valves and hoses as well. So now that I have all these sorted, I'll group them under one null called hydraulic 1 null. And then we'll have two nulls under that, hydraulic 1B null and hydraulic 1A null. So now we've got our two groups. Okay, so now I'm going to basically rig this so it behaves like a shock. And first I need to organize this a little bit more. So basically I have hydraulic A and hydraulic B, but I want the ball to be separate because the ball is the part that moves. So I'm going to grab everything except the ball and I will put it in a group, and I'll call this hydraulic 1A aim. And then I'll grab these two as well. And then we'll just copy and paste. Oh, and I forgot to name them null. So let me just throw that on there. And for this one, you'll notice the pivot is at the origin, as with all groups. So let me just go ahead and move this up to there. So now we've got this piece that can kind of move around the ball. So rather than grabbing this ball piece, I'm going to actually create some handles here. So what I'm going to use for that are NURBS curves. So I'm going to go over here to create NURBS primitives, and I'm going to create a couple circles. And let's scale these up. Well, you do 5. And then this will be hydraulic 1A handle. And then let's duplicate this and call this B handle. And I will just move that up to this point here. So I'm gonna just copy this name because I'm also going to create a couple of locators. Let's do locator, and we'll do the same value, 5 here, and then let's call this a aim, and we'll parent this under a handle, and then let's duplicate this thing. To this point here. Make sure it's still centered. And we'll parent this under this one. So now we've got handle and aim. Let me just drop this in my hydraulic null. So we'll make sure that all the transforms in here are frozen, actually. And we'll grab our 2 locators and scale them up to 5 again, because I just kind of want to see them for now. So I want this ball to basically move with the handle, this circle. So what I'm going to do is I'll grab the circle, grab the ball, and I'll just go to Q so we don't see the manipulator. And I will go up here to animation, constrain, and then let me open parent constraint. Let's just reset the settings. I think everything is what we want. And then we'll just hit apply. Now you'll see in here, under hydraulic B ball, you'll see this constraint lives under here. And if you ever want to break this connection, easiest way is just to go grab this constraint and delete it. But since we have the constraint there, now when we move this handle, the ball moves with it. So let's do the same thing down here. Cool. So now we've got this one moving as well. So the next step is I want this group basically to be parented to this locator. So I'll grab this locator, grab the group, and do a parent constraint. And then same for this one. I'll grab this locator, grab this group, and parent constraint. And so now you'll see that pretty much everything moves with it. So the next thing to do is I want these locators to basically aim at each other. So I will use an aim constraint, and let's go ahead and reset the settings. The only thing I'm going to change in here right now is this maintain offset. So I'll grab this one and hit do an aim constraint, and then I'll also grab this one and do an aim constraint. So they're basically going to just aim at each other. So that is going to be our basic shock setup, and what's cool about this is we can move these around, and then we can also position the ball. So it's a pretty versatile setup. Now if I just zero this out, goes back to our vertical orientation. So now that we have our first hydraulic built, we can start to position it around our motion base and create that mechanism. So since I'm definitely going to be duplicating this part around, I definitely want to lay out some quick UVs. Similar to our agreeable parts, I just want to have them basically cut and unfolded, and then we can pack them again later. So you can see there that I've done basically just a planar map to get some basic UVs on the surfaces, and now I'm going to cut this first ball as if it were a cylinder. You can see the results there. And what's cool about this, having these top and bottom ball and sockets be the same, is that I can transfer the UVs from one to the other. So I'll treat this part as a cylinder as well. And now if I unfold, you can see what I'm getting there. And let me just go ahead and transfer. And then for this part, I can just cut down one side of the cylinder and unfold. And now for the bolts, it would take time to select the 6 edges around there, but if you're clever with your selection tricks, you see I selected basically a ring of faces and selected the perimeter to grab that edge. So I then can, so I can cut this first bolt, and then let me change the sort to alphabetical within type. I'll transfer those UVs to bolt 1 and delete history, and then I can just go down the list and transfer. Now I've got all my bolts laid out. I'll cut this like a big cylinder. And the cool thing is that since I added these little rib parts, but they don't have any backs, they could just unfold pretty easily. So I didn't even have to make any cuts on them. Let me go ahead and cut these edges of these hoses, and then we'll just go ahead and unfold those. And then pretty much the last thing to do are these sort of valve stem areas, and I'll just cut them open as I would any other box and transfer the attributes. So now let me just pack these really quickly, set it to world prescale, and I'll set the rotation angle to free, and then that should be good for now. Go ahead and delete history. Alright, so now that I have my hydraulic built, it's time to kind of configure it into the motion base. But the first thing I want to do is duplicate this hydraulic, because we're going to be using it for another exercise, and I want to just keep one around just in case. But since we set up a rig, we're going to need to do a duplicate special. And let's just go ahead and reset the settings here. And I want to make sure the duplicate input graph is checked. So now let's duplicate special. And we'll just hide our original. And let me show the motion base. Let's actually work this direction. So let me grab the top null of my hydraulic 1, and I'll rotate it by 90 just to kind of match the angle of this shock in the blocking model. So I'll snap it to that corner and rotate it so it vaguely matches the angle, and then I can just move this handle to actually aim it at the top part of the motion base. Actually, let me line this up with the shock a little better. Snap it to that point, and then I can sort of move this down. And I'll actually snap it to this point up here on the top plate, and can hide my blocking model, and I'll do a little better job of snapping to that corner. So now I can duplicate special this first shock and just move it over here, and looks like I'm going to need to do a little math on the angle. Actually, I think what I'll do is I will kind of round this angle out to 68 degrees, and then I'll re-snap the top handle here, and then it'll make it a little easier to do this math. So I'll just rotate this to 112. And let me hide my blocking model, and then snap this handle into place where it needs to go. Cool, so now I've got one side of the motion base's shocks done. Let me grab those two and duplicate special, and I'll just put those in a group and rotate it by 120. And that'll give me my second side. So then let me unparent those, duplicate special, and throw them in another group, and we'll do -120 for them. and then I'll just go ahead and unparent those. Let me just hide my blocking model stuff, and now I've got all 6 shocks that we're going to need for this one motion base. Now, since these are all going to be in a motion base together, I'm going to want to rename them. So since we set this hierarchy up with the prefix of hydraulic 1, we can simply go in with Maya's search and replace and just replace the numbers at the end. So hydraulic 1 gets replaced with hydraulic 2, etc. And now I can group these all together, and I'll just call this motion base 1 null. So now I'm going to, let me hide this cone in the center here. Now it's time to design the plate at the bottom here that these hydraulics actually attach to. So I'm going to start with a cylinder, and I want this to be divisible by 3, so I'll change the spans to 24. And now I'll add a subdivision on the cap as well, because I think I'm going to want this to be a hollow ring. So now I'm going to grab these faces on the 3 sides of the cylinder and just extrude them out, and this will kind of help me to visualize where this what this plate's going to look like. But I think I want these hydraulics to mount onto kind of a round detail. So I'm going to create a couple cylinders. Actually, I'll change the one cylinder to 12 sides, and then I'll delete the other. And then I can just type in the negative value to get the same value on the duplicate. So I'm going to work on this as a flat piece of geometry right now, so I'll delete all the faces on the sides and of these pieces and just snap the rest to the origin. I'm going to extrude this one side of the cylinder out and delete the faces I don't need. I'll extrude and snap that edge to the center. And then what I can do is combine and merge this piece. I can change the pivot point of this to the origin and just duplicate these around. And I'll go ahead and combine them and change the pivot point to the origin again. And then I can go in with my append polygon tool and connect these edges and kind of give us the outer shape that we want. So for this cylinder shape in the center, I'm going to actually delete those extrusions that I made, and we're going to just combine this part. And using the append polygon tool, we're just going to connect these 6 edges around the cylinder. And much like the radial exercise, what I'm going to do here is just work on one spoke of this piece. Let me split these long edges here so I can split it in half, and then just work on basically 1/6 of this piece. So let me grab this face and I'll cut an edge across there, and I can snap these vertices to the right spot and use my append polygon tool to kind of fill that hole. And then I'll use my multi-cut tool to fix these edges up a bit, just to give some support to that rounded corner. So now what I can do is mirror this, and then if I change the pivot to the origin again, I can duplicate rotate by 120 and then just hit Shift D, and now I've got my 3 sides of my motion base. So let's combine and merge these pieces. Now we've kind of got the basic shape of this motion base plate. So now I'm going to add some thickness to this plate. So I'll just extrude up, and we'll do a value of 1.5. And I'll assign my agreeable material. So I can kind of see the basic shape that we're working with here. So I want to use the bevel tool on all these edges. So I think what I'm going to do is go to the side view and select all these side edges, and then change my selection to edge perimeter. And now I can go in and select all the edges that I definitely want to also be beveled. It's kind of a time-consuming way of doing it, but I just wanted to be sure that I was only beveling the edges that I wanted to. So now turn chamfer off, offset as fraction off, and let's use an offset of 0.3. It's looking pretty good when I smooth it out. And now I can just go in and connect some edges. So let me again work on the third of this, delete the rest. And I think I want to add this edge loop in here just so we're not, just to support kind of the inner ring of this piece. So I'll just connect these edges like so. And I think I'll connect these across this way. And same on the other side. So let me go in and delete these edges that I don't want in this area. And I think rather than doing the same thing to the top and bottom, I'm actually going to split this piece in half, and then we'll just delete the bottom side. So that way we can only work on the top side and then mirror it later. So let me just connect those edges that way and delete the ones I don't need. I'll snap that one to place. And actually connect that one across. So now I can mirror a negative Y. Oh, but you can see that I missed an edge there. So I'm just going to select these edges and quickly use the bridge tool. And I think I want to add some more relief to this piece. So I'll grab these faces here and just extrude up. Let me unhide my shocks. Actually, let's go up to this. Let's go up to this point there, and then we can just scale those top faces in, and push these back. That kind of gives us a little hint that there's some sort of mechanism or something in there. So I think I'm gonna grab actually I'm gonna grab these edges that I definitely want to use the bevel tool on. And let's go ahead and use it. Chamfer off, offset as fraction off, and 0.3 to match the rest of the motion base. And now I can just connect these edges on the back. Sometimes it's easier to just figure out what one area needs after the fact. I think I can connect those like this, delete these edges as well. Actually, let's go ahead and connect these down here. Delete the extra edges. Cool. Now let's work on how these connect. Actually, I'll keep those ones there. I can kind of connect this way. Actually, yeah, let's connect it like that instead. It just goes from corner to corner. Well, so that's cool. I think I want to do something similar with inside of this ring as well. I'll give some thickness to that. So now I'm just going to create another 24-sided cylinder. And you can see that we've lost some of the curvature when we did the bevel tool. So I'm just going to use my point snapping and just get some of these vertices back in the right spot. Go ahead and delete that cylinder because it was just a guide. And now let's extrude this part up. I'll slide the edge back. Let me delete these side pieces, and then I'll just split the edge and delete the edge on the corner. Now I can delete that edge as well. And before I bevel this, I think I'm going to just drop in an edge to add another level of support to that transition there. So I'm just throwing in an edge loop with multi-cut and then snapping it down so it's flat. So now I can just bevel those top pieces with the usual settings. And then I can delete these extra edges. Cool, so now I can duplicate this, rotate by 120, combine and merge, and let me just soften the edges, and now we've got basically our bottom motion base plate piece. Call this motion base 1, plate A. And now I'll go ahead and duplicate this piece. Make sure the pivot's in the right spot before I do it, and call this motion base 1 plate B. Rotate it by 180, and we'll just move it into place up here and eyeball where it intersects with the shocks. So I want this plate to be relatively the same height in Y, so I'm just going to scale it down in these two axes. And I want to line up basically the center point of that curved area with the center point of the shock. So now that that's somewhat aligned, I'm going to go in and grab the verts, and then I'll just drag those verts over. Let me actually deselect those ones. And now what I can do is delete everything but that area that I've edited. I can mirror this piece over, fix the pivot, and I'll go ahead and do my duplicate and combine. So now I can merge all the verts, and then if I delete and replace those edges, you can see that now we can straighten those sides back out. Let me scale up this round piece in the center, just to somewhat match the bottom. It's too small of a space to actually match the bottom perfectly, but I just want to get it a little closer. Now what I can do is just sort of move these verts around so we get a nice straight shape. Then I'll delete the other 2/3. Put the pivot back at the origin, and duplicate, and duplicate. Combine and merge, and recenter the pivot. And now we've got basically our top plate. Oh, so you can see we're getting some intersections with those blocky parts. What I'm going to do is actually just move them up so they're out of the way. And then I'm actually going to scale these so it kind of matches the right angle a little more. Cool. So now if I hide my blocking model and soften the edges, we've got our 2 plates for our motion base. Alright, so now it's time to rig up this motion base. First I'm going to delete some of these groups that are hanging around, and I'll rename this to plate B, and then I'll parent the 2 plates into the motion base null. I'll freeze transforms on those plates. And now I'm going to want to create a couple of controls for this motion base. So I'll create another couple of circles. Scale this one up. Let's just go with 45. And I'll call this motion base 1 handle A. I'll duplicate and snap it up here and scale it down. Let's scale it down to 30. And then this will then be handle B. Since handle A is going to be what I grab to control the entire motion base, I'm actually going to unparent it and then parent all the other parts of the motion base to it. So now if I were to rotate this around, you can see that everything in the motion base comes along for the ride. So I want to make sure before I create any parent constraints that my 2 handles have frozen transforms. So in order to do that to handle A, I'm going to want to unparent the motion base from motion base handle A, grab the 2 handles, freeze the transforms, and then I can reparent the motion base null under motion base handle A. So now I can grab motion base handle B and create parent constraints between it and all the top controls of the hydraulics. And finally, I'll create a parent constraint between handle B and plate B. So you can see that I can now take handle B, move it up and down, move it side to side, and even rotate it around, and all the hydraulics work as you would expect. And now if I zero it out, it returns to its rest state. So now the last thing to model is a wire loom that will connect the body of the space vet to the engines. One other thing I can do in this motion base is, now that we have everything hooked up, we can actually hide the control curves for the hydraulics themselves. Just because the only control curves we really need to see are the 2 handles for the motion base. And after taking a second look at this, I think I'm going to actually lengthen the piston shafts of the hydraulics. So I'm just going to grab everything, switch to object mode, and then we'll just move them down a bit in object mode, just so we can have a little more play when we're moving the top of the motion base around. Obviously, if we take things too far, we'll see the disconnection there. So the last thing I wanted to add to the motion base before actually adding it to the space vet itself is this kind of cluster of hoses in the middle. And that was basically just to kind of suggest that there's some kind of important linkage or fuel or wiring that needs to go from the body to the engines. So I just used some basic cylinders and kind of moved the edges around, and you can see that it's a pattern that repeats 3 times, and this one in the center just has a bunch of ribs, but nothing too complicated, and I just threw them in a group. But now what I'm going to want to do is actually create an aim constraint with this group and this controller. So let me open up my aim constraint window, and I'll just grab this. I'll grab the motion base hose null, and we'll just I'll reset the settings and click maintain offset, and then let's just hit apply and see what happens. So when I move this around, it's kind of not doing really what I want with these hoses, because it's confused about the axes, and it's kind of making it so these things spin around really awkwardly. So what I'm going to do is actually undo that constraint, and I'm going to change the aim vector to Y, since this is facing straight up, And I'll just go ahead and hit apply. And now you can see when I move it around, it kind of just rocks back and forth. So when we put this on the space vet, it'll just kind of simulate that there's something down the center of this motion base. So let me zero this out. And I think that's going to be it for the motion base, so let's move on and build some landing gear. So the other thing I want to do with the shocks this week is create some landing gear. So you can see here that I've blocked in basic landing gear shapes and animation, and this kind of gives you an idea of both the motion you want and kind of where you're going to want to put shocks. I think I'm going to put one at this diagonal here to kind of pull the leg up and down, and then I'll put one here to move the foot as well. So let me unhide my hydraulic and move it off to the side, and we'll go ahead and duplicate special. And I'm actually going to use this hydraulic to create the main leg of the landing gear. So let me just snap it into place, and I'll rotate it down this way. Scale it up so it's about the right size. And let me hide this cylinder in the middle. And I think I'm going to lose the valves for this landing gear leg, just to make it look a little different from the hydraulic. I'll rename it landing leg 1 null. So now I'm going to use this cube to kind of create the foot piece. Move these verts down and over this way. Actually, I think what I'm going to do is kind of create the pivot first. So cut an edge in there, and then I'll just extrude this. I'll just extrude this face up, and then I can grab those edges on the corner and do a bevel, and we'll just drag the fraction up so that it makes a kind of a half circle shape. So now let me isolate this piece, and I'll just I'll move these verts up so they line up with this half circle. And I'll try my triangulate trick, but it won't quite work. But sometimes you just have to help the triangulate trick along. In this case, I just needed to cut that one edge. So now I'm going to use my cut faces tool to kind of carve in where the rest of the foot shape's going to be. And let me extrude back here. And I'll just create kind of an interesting angle. And then I'll also extrude this face up here up, and just kind of extend the front of the foot. So now I'll just extrude the sides out and scale them out. I'll grab these verts on the front, except for those ones, and throw a lattice on it. And then I'll give the toe of this thing kind of a taper so it looks more like a ski. I'll delete my history. And I think I'm going to want a little more interest on the lower side of this landing leg, so I'm going to actually duplicate this piece. And we'll just move it down, rotate it around. And I think I'll delete those fin pieces, and then I'll move some verts down. And that kind of just gives this a different feel than the regular hydraulic. So now I'm going to take my landing leg null and animate it. Having the animation on there really helps when you're actually placing the shocks. So I'll grab this foot piece here, and we'll run auto crease and the bevel tool, and we'll just clean up the topology like usual. There's not a whole lot going on this piece, so it should be pretty quick. And And now I'll assign my agreeable material. We've got our basic ski. So I can delete the ball and socket since we've created a different piece. Or just the ball, not the ball and socket. But I'm going to rename hydraulic 1 landing leg 1. And I'll name this landing leg skid main. I'll take SDM off for now. So, actually I need to move these verts so they line up a little better. And I kind of like it. It gives the front of that skid a little curve. That's kind of cool. So I'll just leave that in there. I think I'm going to change this ankle piece a little bit. I'll scale these flat and then out, and then we can just extrude those in, and then maybe drop a couple edge loops, and that kind of gives it more of a less of a ball shape and more of a like an ankle shape. Let me adjust the pivot point of this piece to the right part of the ankle, and I'll parent this piece under landing leg 1B, and I will set a key, and then we'll just counter animate so it stays level and it folds up. I'm going to create the shape up here for the actual mount of this. So just create this cylinder and snap it up here and just kind of scale it in place. I can move this box out of the way while I work. First extrude half of that cylinder up. I'll turn retain component spacing off, and then I'll just snap them and delete those faces. And I'll extrude this back and match that angle a little bit. And I'm going to fill this hole and connect that edge, and then I can delete the old ball. So this is going to be where this thing pivots from. Let me extrude that up. And actually, I think I'm going to have to actually place the shocks just to know where the footprint of this thing is going to need to be. So let me start with that. I'll grab this first hydraulic and go ahead and duplicate special. And I'm going to bring this over to the foot. We'll rotate it 45 degrees. But it's obviously really big, so I'll scale it down to scale it to 0.75 and move that into place. And now I can grab this handle up here. Oops, I grabbed the handle and the locator. Make sure you just grab the handle. And I'll move that down and then just rotate it into place. And there you have that. So let me duplicate special this piece, and we'll just go ahead and reset this. And actually rotate it by 180, and put it maybe like there, and then move this piece kind of this way. So I want this all to line up, so I'm going to move this kind of collar piece that way. I'll move the bolts as well. And then I'll just move this whole thing down. So now I can just move the handle out this way. And now we've got our basic landing gear shock set up. So let me hide hydraulic 1. And let's go ahead and I'll grab this foot and then hydraulic 1. I'll grab this foot and then this lower hydraulic and create a parent constraint. And then I'll grab this collar piece, create another parent constraint. So now you can see when I do the animation that we are effectively breaking our hydraulic, but we'll fix that in a moment. So let's rename this to landing leg shaft. So now I'll create a group called landing leg 1 null, and I'll put the hydraulic and the landing leg shaft groups in there, and just double check that everything's still working. And now I can create a parent constraint between this collar piece and the upper hydraulic, and you can see that's now working. And now here what I want to do is kind of split the difference between the upper and lower half of this hydraulic while avoiding any intersecting pieces. So now when I scrub through, you can see that this thing is working properly. And now I can go in and work on this mount piece where everything attaches. Extrude that up and across like this. And I'm actually going to use my cut faces tool again, and then we'll just let me delete that. Went too far with that edge, and then I'll just extrude this parts out and just make them even with the kind of foot part. So now let's use auto crease and use the bevel tool to get our supporting edges on this, and let's just clean up some topology. Delete those edges. And it looks like we forgot to grab that edge, so I'm just going to quickly create these supporting edges. Well, so now that piece looks pretty good, and now we've got our landing gear all animated. So now I'm going to go ahead and integrate the motion base and the landing gear with the space vet. Alright, so now back in my space vet scene, I'm just going to go ahead and import my motion base and landing leg. And I'm going to go to the namespace editor and just delete that namespace, just so we have nice clean names. Let me delete the stuff that was in that scene that I didn't necessarily need. And now I've got my motion base and my landing leg. So let me pull out the motion base first. I'll rotate it 90 degrees in X and also in Y, just to get it into position. And then I can kind of just snap it into the center of that piece there. I'm going to want to duplicate special with the duplicate input graph checked, just to reiterate. And I'll just snap it to the center point of this one and just kind of scale it up. And I can just move it into place. Cool, so now I've got my motion bases kind of placed. I can now delete my temp group. And I'll just delete the temp layer as well. Awesome, so now I've got my motion bases kind of integrated with the rest of the greebles and attached to the engines. Anytime you want to see your model without the NURBS curves, you can go up to the Show menu and just uncheck NURBS curves, and it'll hide the NURBS curves. So I want to give these two motion bases unique naming, and the quickest way to do that is to actually just add another prefix to the name. So under Modify, there's Prefix Hierarchy Names. So for this one, I'm going to prefix with L front. And I'll prefix this hierarchy with L rear. And just fix that naming. And now we're going to put these two motion bases into the L space vet null. So the other thing I want to do is make these engines kind of be part of this the motion base hierarchy. So what I'll first do is delete the keyframes that are on there. And I'm going to want this curve to kind of drive the engines themselves. But since the curve is kind of on the inside of the engine, it's really difficult to see and select. I'm going to actually move them to the outside of the engines. But you see, if we grab the curves in object mode, that they actually move the whole motion base, because that's how we've set it up. But if I go to component mode on the curves and grab the actual control vertices, you can see that I can move those around, and then they still affect the motion base as you would expect. I'm just going to straight up parent the engines to those control curves, and now you can see if I grab that curve and move it around, you can see the motion. You can see the motion base behaving accordingly. So I want these engines to kind of rotate around, but you can see if I rotate this outer control curve too much that the motion base rig starts to break. So I imagine that the motion base would be used more for angling the engines, and that the motion base would be mounted on a pivot so it could rotate for vertical landings and takeoffs and that sort of thing. So now let me place the landing gear. When I was looking around at where I could put this landing gear, this spot kind of seemed like the obvious place to put it. It's kind of evenly spaced around the body, and there's that natural cavity that it could kind of sit in. So I'm going to just place it in there, and maybe scoot it back a bit. And then if we look at the animation, we can see what we're getting there. And now I just need to delete that greeble pipe piece that I had in there before. So let me duplicate special, and I'll go ahead and rotate this around -90. And you can see that it's a bit of a tighter squeeze in the back here, and I might have to shift some stuff around. So I'll just place it as best I can for now. And you can also see when I close up the landing gear that it kind of intersects with this boxy piece. So let me actually rescale and reposition this piece. And it kind of makes a tight squeeze back here, but it's kind of cool. It makes it seem a little more intentional, like every piece is perfectly placed to not intersect with each other. Move this big shape out. And then we move this plate in a bit. And now we've got enough of a cavity for that landing gear to sit in. You can see we can scrub our timeline and see our animation happening. So let me also recreate the animation on our engine parts. So I'll just key the rotation and then just rotate it into place. And do the same thing for the back engine. And now I can grab that outer handle and sort of rotate these, rotate the engines to match the concept a little better. I'm gonna actually undo that though, because I didn't key the position of those. So now you can see what's happening, but we're getting this weird bowing effect with the motion bases. And what's basically happening here is if I select this, you can see that the main rotation we're dealing with is rotate Y, but you'll notice that rotate X and rotate Z are flipping. So it's giving us kind of a weird animation. If I just delete those keyframes, you see that we get the behavior that we want. Basically what happened in this case was I had rotated it by 90 degrees in X and 90 degrees in Y, but what I really should have done is rotated it negative 90 degrees in Z, and I would have gotten the correct order of rotation, I guess, to get this to behave the way I wanted. So the other thing I want to change here is you notice that my engines and landing gear were all moving at the same time, and I think I want to stagger that animation. So I'm going to just grab the two motion base handles, and then if I shift, click, and drag in the timeline, I can actually move the keys around on the timeline. So I'll just move those once to 10, and then I'll move the keys on the outer handles to start at 15. And that just kind of gives a little more interest to the animation, so it's not all happening at once. You notice I forgot to put the landing gear inside of the hierarchy, so let me prefix them with L front and L rear, and then I'll just pop them in there. And now if I duplicate special and mirror the left hierarchy, we can have our left and right side and see what we're getting. So I'll hide the NURBS curves again and just drag, and you can see that we've got our basically landed and mid-flight versions of the SpaceVet. So now I wanted to do a bit of housekeeping on this landing gear. So you can see that I've added this rubber pad to the bottom, but there were a couple things about this hierarchy that weren't behaving optimally, and a couple things that I wanted to fix in here. So you notice that the this lower shock is kind of parented to this landing skid piece, but really what should happen here is this should all be in a null down here, this whole landing skid. So let me delete that parent constraint and let me just grab these three pieces and group them together. And we'll call that L front landing leg skid null. Oh, and I also forgot that I had keyframes on this landing skid, so let me just go ahead and open the graph editor and just grab those keyframes and delete them. So now I can put that animation onto the group itself, but first I'm going to basically align the pivot so it's in the right spot. We'll set a keyframe on Z on this frame, and then go up to frame 10 and set the key to 60 so it lays flat. And now go back to frame 1, and we'll actually do a parent constraint of this lower handle of this lower shock onto this group that we just created. The other problem we're having is that we don't have these bottom parts of this this main strut of the landing gear, we don't have them parented in the right place. So just make sure those are all in the B aim group. And now you can see if I move these pieces around, it works. So let me also parent constrain that lower handle into the landing skid null. That way we can have some action where it looks like it's compressing when it's, if we do some kind of a landing animation or something. So the other thing I want to do is actually grab all those handles and hide them, since they're not really handles that we're going to be grabbing to animate, so they don't need to be visible. And I think what I'm going to do is replace L front with simply the letters LF, just so we can keep the names a little shorter in this asset. And I'll also shorten the word hydraulic down to just HYD for short. And then I can actually appropriately number each hydraulic, so everything has a unique name. It so happens that at ILM we have a proprietary software that doesn't allow for duplicate names, so having unique names on everything is something that I've kind of worked into my own workflow, and it can be a little difficult at times to keep track of everything, but if you use prefixes and suffixes in a clever way, you can get around that problem relatively easily. So since we abbreviated the front to LF, I think that I'm going to abbreviate the L rear stuff to LB for back. The reason I'm using B instead of R for rear is R is kind of what I would use for right, so I don't want any confusion there. So it's going to be LF and LB for L front and L back. So I'm just going to type up in the search field up there. If I do star rear star, it'll select everything in the scene that has the word rear in its name. And it's kind of just a wildcard naming selection. So now I've got everything in the scene with the word rear in it selected. But Comet Rename is really bad about renaming a lot of things at once. So I'm going to actually go in here to the Maya, to the native Maya search and replace names, and we'll search and replace rear with a capital B for back. And this will take a minute because there's a lot of pieces. So while I'm at that, I'll go ahead and do the same with front. But I'm going to want to be careful because, as you'll notice, it has selected the front camera, which we definitely don't want to rename. So now I'll just search and replace front with F. Also now I can exit my renamers. And I'm just going to duplicate special my front landing gear. And I'll actually grab the LB landing leg that I had before, and I'll just transfer the attribute values. And then I'll just do a rename of LF to LB for the front and back. And then I can go ahead and delete my duplicate left side space vet null. And now I'm just going to do a bit more organization here. First I'll put these radiator fins into a radiator null. And I'm going to actually do some more editing of these control curves. So I'll make the back one a little bigger since the back engine is quite a bit bigger. And the other thing I'm going to do is change the color of them. And to do that, we go into the attribute editor on the handle shape node. And then if we drop down this palette called drawing overrides and enable overrides, then we can kind of drag the color along. And if you drag along, eventually you'll find this yellow, and this is the yellow that I'm going to use. So I'm also going to move and resize the curve that controls the actual base of the motion base. So I'll grab those control vertices and just kind of move them out and scale them up. Then I'll enable my overrides and move them to that yellow color so they all match. So now I've got some easy to see and easy to grab handles for my motion bases and engines. The other thing I want to do at this point is actually move the space vet up so the landing gear is actually landed on the ground plane. So I'll grab my space vet null and I'll just change the pivot to the bottom of the landing gear. But I'm going to want to move all the other stuff in my scene that corresponds with this, because we've already aligned a lot of stuff. So I'll grab the base vet, the sculpt, the blocking, the guide curves, even my low-man duplicate, which is I've actually positioned to be the driver. And then I'll also get the concept cam. So I'm going to just eyeball that up to the origin, but I only want to snap the space vet null to the origin, because if I snapped everything, all their pivots are in different spots and they would all just snap to wherever their pivot is to the origin. So the only one that I really cared about being precisely at the origin is the space vet null, so that's the only one that I did. And you'll notice that if we go to concept cam, that our concept cam did not come along for the ride. And the reason for that is because I would actually lock the transform values on the concept cam. So since I moved the space vet up a value of 80, I can just add 80 to the value of my concept cam. If I add 80 to 295.154, I get 375.154. So now that I've entered that value, I can lock select it. And now you can see that it's perfectly aligned again. And I can go ahead and lock that value. So I want to create a couple of handles for the space vet itself. And I'm going to actually want two of them. One is going to be for the entire hierarchy, and it's going to control all the animation that we do on the space vet as a whole. So if we animate it to fly around or something, that animation will be on that control handle and not on our top null. But I'm also going to want another control handle, and that's going to control just the body. And that way we can animate some compression on the landing gear if we do like a landing animation or something. So in order to get the handle, I've used the create polygon tool from the top view, and I've kind of just traced a shape on the outside of the space vet itself. And you can see it's kind of just this polygonal shape. And I'm going to actually use that shape to create the curve that's going to represent the handle for the body. So I'll come to my CV curve tool, and I'll make sure that the curve degree is set to linear, and then I can literally just point snap around here and just go all the way around this shape and hit enter to finish the curve. And I'll just raise it up by 80, since that will be about where the space vet will be. So I'm actually going to duplicate this and scale this out, and that's going to be our main handle. So let me just name this space vet. I'll call this space vet, and I'll call my other group space vet geo, and then I'll call this inner one space vet body control. And let me do the drawing overrides and make these yellow as well. And now you can see if I grab my main null, I can move it around. And this one, though, is going to just control the body, so we can actually control the body kind of independently of the landing gear feet, and that'll give us a little bit of bounce and compression when we do animate a landing sequence or something. So this. But in order to do that, I'm going to actually have to separate out the stuff that's going to be actually part of the body. So let me just grab I'll grab pretty much everything except the landing legs and put them into a group called L body null. And I'll do the same with the center stuff, C body null. And then for the landing legs, I'm going to want to separate basically the lower part and the upper part into a group that'll be for the body and a group that'll be for the foot. So right now you can see that of the main part of the leg, I have both parts under this sort of shaft null, but really only part B needs to be under there because part A is aiming at that area. So you can see that if I move part A out of that shaft null, that the animation still behaves properly. So I'm going to actually rename this to LF landing leg 1 ground null, because that'll represent my what's touching the ground. And then I'll grab the rest and call it LF landing leg body null. Now I can grab the L body control and parent constrain the L body null, and then also parent constrain the C body null. And then I can actually parent constrain the landing leg body null. And now you see if I move this up and down, we get this kind of compression in the landing leg. It's kind of cool. I mean, it adds that extra layer of functionality to the mechanisms that we've built. But what I do have to mention is that typically this step where I do all these parent constraints and stuff like that is something that I do at the very end when the model is totally complete. Having all these constraints can kind of screw up other things we do. So you'll notice that if I actually duplicate special our L space vet null and mirror it over like we always do, that now I'm getting really bizarre results. And the reason is because of the parent constraint relationships that we made. So if I go ahead and let me find all those constraints and just delete them. And then the last one is in here at the landing leg. Now you can see that I moved that curve around, and I don't know why I have duplicates. You just delete those. But now you see if I move that curve around, that we're not seeing any movement in our body parts anymore. But if I mirror my L space vet null over to the right side now, everything looks as we expect it to. So really, as I mentioned a minute ago, this step of hooking everything up like this is something that you really have to do at the end to really get the clean results. And I might even go as far as reconnecting all the aim constraints and stuff on our landing gear and motion bases and stuff. But we'll see when we get to that point what I actually end up having to do. So the last thing I want to show this week is how to set up a set-driven key. So right now, this landing gear, we have this animation that we've done. So we have a keyframe on landing leg 1B, and then we have a keyframe on landing leg 1 skid that kind of counteracts the rotation and keeps the skid level. But it would be really cool if we could control this animation from our master control. So what I'm going to do is grab this master control, and we're going to go up to Modify, Add Attribute. And the long name is going to be, let's just call this LFLL deploy. And we'll leave it as float. We'll set the minimum at 0. Let's set the maximum to 1. And then we can just hit add here. Now what we can do is, let me isolate my landing gear. Now what I'm going to do is, I'll take this landing leg and we'll just do a duplicate special, and I'm just going to unparent it and move it over here. And you can see we've lost our, whenever you see something turn green like this, it just means we've lost our connection to the shader, so I'm going to just assign the greeble mat again. Doesn't really matter though, because this is going to be deleted. So we're going to go to our landing leg ground that has this first keyframe on it, and we're going to actually just delete the keys. Alright, let's open our graph editor, and we'll just go ahead and delete those keys. So now if we scrub here, we just have the one on the foot. So let me get the skid group, and then I'll delete its keys as well. And the reason I've duplicated this off to the side is I want to see what those values are. So now what we can do is go to key, and this is under the animation workspace, I guess. And we're going to go to key, set driven key, and set, and we're going to open this up. We're going to go to the space vet, and we're going to load the driver, and then for the driven we're going to load this LF landing leg ground null. So let's load driven. Basically what we're going to want to do is have LFLL deploy here, drive rotate Z. So if we go here, I'll go to my space vet control, and since this is deployed, I want to set LFLL to 1, and we'll set a key here. So now if I set LFLL to 0 and I go to my ground null and set this to 90, we'll set another key here. So now what you can see is if I grab the space vet null and I click on this LFLL deploy and slide it, now you can see that I get my action there. The other thing I want this LFLL deploy to affect is the rotation on this landing skid null. So it's going to be also rotate Z. Let me load the driven, and then we'll do rotate Z here. And space vet right now, so right now it's set to 1, so we're going to want to set the key. And now let's set this to 0. And now we are going to want to grab this and do our 60 degree and key that as well. So now if I go to my space vet null, I can control the deployment of the landing gear from just this one attribute. And I'm going to want to do this to one landing gear at a time, because in order to give life to a performance, you're probably going to want to offset the frames of those landing gears so they don't all deploy at the same time or at the same speed. But again, as I said, setting up rigging stuff like this is definitely something you want to do when your model is finished. So I'll be redoing this later, but I wanted to demonstrate how to do it now to just kind of show the potential and the rhyme and reason behind the workflow that I use. So this is where we are at the end of week 7. What I'm looking for this week are your mechanical parts rigged up with control curves ready for animation, and I'd like to see at least one working set-driven key. The assignment this week is definitely more of an exercise in that I'm not expecting to see a completed rig with your completed model at the end of this class. While some of these rigging skills aren't necessarily required of a hard surface modeler, I think they are valuable workflows to know. I find these tools extremely valuable for designing mechanisms and illustrating how they function. If you set up basic rigs like this in film production, it's a toss-up whether the rigger will use your work or throw it away and start from scratch. I've literally had both cases happen to me. As I mentioned in the lesson, a lot of these workflows should be used when the model is fully completed. I would therefore recommend saving a version of your file before doing any heavy rigging work. There's definitely an art to mechanical rigging, and we've barely touched on the tip of the iceberg. If you'd like to learn more, I definitely recommend taking a mechanical rigging course. If you run into any trouble this week, don't hesitate to ask questions, because I know some of this stuff can be very technical. So as always, thank you for watching, and I hope you have fun mechanically rigging your model.